So we're going to continue on looking at the binomial expansion. So here was Pascal's triangle that we looked at on the previous example. The coefficients are the same as the combinations, so we can write these all as combinations as well. So when we're using our binomial theorem, we don't want to have to memorize Pascal's triangle and keep building it. We're going to use combinations. So here's the pattern or the rule for the binomial expansion. It looks a little overwhelming when it's written as symbols, so I tend to just sort of remember what I need to do, but I'm going to explain it to you here as well. So x plus y to the exponent n, and it's simply the rules that we had looked at in the previous example. So your combinations always start with your n value, and you would say n choose 0, n choose 1, n choose 2, and you would continue until n are the same numbers. You start with the first term in the binomial, so x, for example, and it's going to be the first, to the power, and you just count down, so n minus 1, n minus 2, until you get to 0. Then you're going to use the second term. You start at 0, and you simply just count up until you reach the n value. So it's really describing in symbols the rules that we're going to use and what we looked at with the characteristics. So let's use example 1 to see that then. So expand the first 3 terms of x plus y to the 8 now. So there's actually 9 terms. We're just going to write down the first 3. So what I do is I like to think of one thing at a time here, and I think of the combinations. So I'm going to have 8 choose 0. I'm going to leave a space because I'm going to write more information there. 8 choose 2. Or sorry, choose 1. 8 choose 2. So I always count from 0. That's important. So 0, 1, and 2. So that's going to be my combination. Then I choose the first term, so x, and I start with the n value. So and I count down x to the 8, x to the 7, x to the 6. And this would continue to 9 terms, but it only asked me for 3 here. Then I choose the y. Now the y does appear in the second one, but I always put it in here as a placeholder, and I remember I just count with zeros. So y to the 0, y to the 1, and y squared. And so now I'm going to simplify this. 8 choose 0 is 1, x to the 8, so I don't need to go 1x. We'll just say x to the 8 times 1. So 1 times x to the 8 times 1 is just x to the 8. Okay, plus, I should put plus symbols here too actually. Plus 8 choose 1, if the r value is 1, then the answer is the n value, 8. X to the 7, y. Plus 8 choose 2. If you've got a calculator, you can put that in there. If you don't have your calculator with a small number, you can use your formula of n factorial over n minus r factorial times r factorial. So these are small enough numbers, so I thought I'd show this. So 8 factorial over 6 factorial times 2 factorial, and you would simplify by going 8 times 7 times 6 factorial. And those 6 factorials would cancel. 2 factorial is equal to 2. So 56 divided by 2 is equal to 28. So this would be 28 x to the 6 y squared plus, and you want to show that it continues. I don't want it to look like there really is just 3 terms in there.